We interact with AI through sleek interfaces and prompt bars, but beneath that polished surface, the infrastructure holding the entire ecosystem together is buckling. The system is struggling under coordination debt, the compounding cost of decisions that were never recorded, dependencies no one fully understands, and processes that grew by accident rather than design. This stack reveals a structural flaw at the base layer. Trillion-dollar tech companies build their empires on open-source projects maintained by a handful of unpaid volunteers. The foundation is physically straining under the weight of the industry it supports. Right next to it is a second vulnerability, the training data. AI models are trained on information with disputed origins and untraceable lineage, creating massive legal and safety blind spots. Now look at the top of the stack, the execution layer. We have moved past passive chatbots. We are now deploying AI agents, autonomous software capable of planning, executing tasks, and taking real-world actions. Because these agents lack shared protocols, they are colliding at machine speed, fighting for compute power and executing conflicting actions in the same digital environment. We are attempting to run a machine speed economy on a paper-thin foundation. As this coordination debt compounds, the system begins to seize under its own weight. Solving this requires a new stabilizing layer inserted directly into the tech stack, the WISE Autonomous Organization, or WAO. This is the institutional intelligence of the stack. It establishes the rules for how agents identify themselves, communicate their capabilities, and resolve conflicts. Coordination is managed by specialized agents within this layer. The first is the Agent Registry Agent, which strips away anonymity by assigning every operating AI in the network a verifiable ID. This registry attaches capability profiles, trust scores, and hard constraints to every agent. No autonomous program can act in the dark. Its identity and its limits are always on the record. The second component is the Resource Arbitration Agent. It manages shared computational resources, like GPU time and API limits, ensuring they are allocated based on priority rather than which agent is fastest. This arbitration logic routes sustained funding and resources directly to the base layer, proportional to the economic value those foundational projects generate. Finally, the Safety Sentinel Agent functions as the ecosystem's machine speed alarm system. The Sentinel monitors the network in real time, immediately flagging any agent that deviates from its declared parameters or uses data from unverified sources. By offloading the mechanical labor of coordination to these agents, the system neutralizes the risk of machine speed collisions before they can propagate. When the Safety Sentinel flags a dangerous anomaly, who actually steps in to fix it? The alarm does not trigger another machine. It escalates the decision directly to a human steward. This relationship is governed by the principle of layered sovereignty. Developers retain control over their specific agents, and enterprises control their deployments. The WAO strictly governs the shared space between them, the protocols for how agents interact, not the work they perform. The result is a stack, where open-source maintainers are funded, data provenance is secure, and autonomous agents collaborate. This architecture provides a path between shutting down innovation out of fear and accepting the risks of unmanaged AI deployment. By delegating coordination to the WAO, we free humans to do what machines cannot, exercise the judgment and stewardship to run an economy that learns.